So congratulations, you've almost made it to the end of day one. Very cool. Today I'm going to be talking about passwords and why they're so 90-90. And what I mean by this is they're kind of old and we've been using them for a very long time. And maybe there's a better way to authenticate on the web. Hopefully I'll be able to demonstrate a new API that will show us a better way. So if you're very passionate about passwords, you can just leave the room because I don't have any nice thing to say about them. Let me quickly introduce myself. Okay, my name is Bellen, and I'm a developer advocate engineer. We just slapped engineer behind my title, so you know that I can also write code. At Auth0, and if you've never heard of Auth0 before, we're basically an identity as a service provider, which means that we try to make it as easy as possible for anybody to implement a secure authentication flow, so you can focus on building your actual products, because nobody wants to be bothered with that. You just want to build your actual product. I'm also a Google developer expert, which means that somebody at Google once said that I know something about something. And I organize a few meetups, one in Belgium about front-end development, and one in London about identity and security. So if you're in that kind of stuff, and you're in Belgium or in London, please join one of these meetups. And you can find me on the internet as Sambeo. The most important slide, I have cat stickers. If you want a cat sticker, just send me a picture of your cat, your dog, your bunny rabbit, whatever. Tweet me one of those pictures, and I'll give you some stickers after this talk. All right, a little bit of history, because the title says passwords are so 90-90. But they're actually way older than the 90s. They've been in use since at least the Romans. There's been some evidence by archaeologists that Romans used passwords. So if you would be a certain group of Romans and you would see another group of Romans and you didn't know each other, you would ask for, hey, what's the password? And if they got the password wrong, you would start the fight. If they got the password right, you would go for a beer or a wine or whatever they did in the Roman time. But they've been using password to identify friend from foe. Then if you go to the 10th century after Christ, there's this famous story about 1001 Nights, which has 40 thieves which steal a lot of gold and jewelry and stuff like this, and they hide this in a cave. And in order to open this cave, you had to say, "Open Sesame." I think most of you might be familiar with this story. It's Alibaba and the 40 Thieves. And this Open Sesame was basically just a password to open a cave full of gold. So whenever you see a cave, just try say Open Sesame. Who knows what happens? But if we skip forward, because we're at a technology conference, the first time that a password has been used with a computer has been in the 1961. A very clever guy named Fernando Corbato, who worked at MIT, invented a time-sharing system. And what it is, basically, in the 60s, not everybody had their own computer. They didn't have a cell phone in their pocket. They had one computer at MIT, but they had a lot of researchers. So they wanted to figure out a way to let as many people use that computer at the same time. Time-sharing, which means that they locked a certain amount of CPU and hard drive for each person, and they could unlock this with a password. So the password was born on the computer. And then at least 9 years later, Robert Morris Sr. came along and invented hashing, which means that at least the first 9 years, passwords were stored in plain text. That's not good. If you take away something from this talk, don't use passwords and don't store them as plain text. Then in the 90s, hacking became more of an issue just because the web exploded. There were so many new websites and apps and services that came on the surface. And of course, when there's a lot of things, some malicious thieves try to steal the data of those lot of things. So hacking became more of an issue. So what is the problem with passwords? You have this login box. It's very familiar, username, passwords. And you try to log in. The first time, you're always wrong. Like, you cannot type your password from the first time correctly. That's impossible. So you retype your passwords. Second time, I must have been nervous. Who knows? Third time's a charm. Nah. So you decide, let me just change my password because I must have forgotten my password. So you reset your passwords. And when you do so, you get a fine error like this. Who's ever had this happen to them before? I have. Passwords can be annoying. If you use a password manager, you might not suffer from this, so I can only advise you to use a password manager. But this is not a talk about password managers, this is a talk about getting rid of passwords. So passwords can be annoying. Passwords also can be stolen. people try to steal data all the time. Most of us store these passwords and other privacy-sensitive data somewhat securely, not all the time, but they can get stolen. So if we get rid of them, they cannot get stolen anymore, which is always a plus. So enter the Web Authentication API. If you were at a talk previously, he talked about FIDO and stuff like this. That's basically what the Web Authentication API is. The Web Authentication API is a browser-implemented API that you can use with JavaScript to do some authentication on the web. It's often written as WebAuthn, so if you want to Google more about this API, just type WebAuthn instead of Web Authentication API, because we're developers and we're lazy, so we like shorter versions. And what it is, it's a key-based authentication. You're going to use a private key and a public key to do the authentication instead of a password. And it uses a hardware authenticator, which can look like this. This is a USB-C one. Who has one of these? 1, 2, 3, 4, 5. Let's say 5 to 6 people in this room have one of these. And that's a bit of an issue, because if we all want to do this, use this cool API, we all should have at least one of these. You have them in USB, you have them in Bluetooth, you have them in NFC, you have them in Lightning for your iPhone or iPad. So I have a whole bunch of them. This one is Lightning, NFC, Bluetooth, also FIPS. If you work for the United States government, you might want to use a special one, Bluetooth. So you have them in a lot of different ways which can connect to your devices, be it a mobile phone through Bluetooth or NFC, or your laptop through USB-C or USB-A or whatever you want. You have a whole bunch of them. You can connect them to almost any modern device. And who has one? I already asked this, 5 or 6 people in the room. If you have one, I have one attached to my computer. Instead of typing a username and password, you might type a username just to identify who you are, but you're not going to type a password anymore. So you type in your username, you click on login, and what we're going to do is basically sign a challenge with that authentication key. My browser asks me to touch my key. That's just so I have an interaction with the key. Mine is also secured with a PIN code, and I have to touch again and allow it because I'm a local host. It's a lot of pop-ups, but when I do this, I basically just got a challenge, send it to this authenticator device, this USB key, and I signed it with a private key that has been generated on that device. And then I get back some data like a public key and the ID of the private key that has been used to sign the challenge. So basically, I authenticated using nothing but this authentication device and not a password anymore. I've asked you who has one of these, and I got 6 hands, but the truth is, who of you owns a device, a laptop or a mobile phone that is younger than 10 years? All of us do. And this 10 years is just a guess, but most modern chipsets, if you have an iPhone, it's the A2 chip, or maybe it's a 3 by now, I'm not sure. Intel has their own chip. Most modern chipsets have a dedicated chip in that chipset that does nothing more but create key pairs and does know how to sign challenges. So every modern device has this built in. So if we take the example we just saw of logging in with an authenticated device, instead of using my USB drive, we're going to use my laptop, which has Touch ID enabled. It's a modern MacBook. So we're going to use this Touch ID to enable, to unlock my authenticated device built into the device and authenticate with that. So same thing, I click on a button. My browser will ask me, can you please touch your Touch ID? I do so. I allow it because I'm on localhost. And I get a ID of a private key back, just the same as I got back from the USB one, but now I've used the internal one. And instead of touching the USB drive, I just touch my Touch ID to unlock the special chip in my chipset. Which is pretty cool, because we all have one of these devices. We are all more or less able to do web authentication with these devices and get rid of passwords. So how does this work? The first thing you need to do when you go to a new website, it's always the same. You create a user profile. So we will also have to create a new credential, a new private and public key pair on our authenticator device. And we're going to use our username to identify ourselves, send this to our backend, and the backend is going to create a cryptographically secure challenge, which is basically an array buffer with random cryptographically secure bytes. Send this challenge to the browser. The browser will relay this to your authenticator device. You have to touch your device, or do Touch ID, or use Windows Hello with face recognition or whatever. You have to do some kind of user interaction. And then that device, the authenticated device, is going to sign that challenge. It's going to send back this signed challenge together with a public key and also the ID of your private key through that Web Authentication API, so you can store those data in your database. It's all public data, a public key. An ID of a private key doesn't really say anything about the private key, otherwise that you can identify it in the future. And the signed challenge, so just so you can see that something has been happened with the original challenge and not that somebody forged a challenge. So by doing this, we just registered a new credential. The next time we want to authenticate, we want to log in, when we come back to the website, we just type our username again. We ask your backend, hey, do you have a credential saved for this username? If so, we send back a challenge again, together with the private key ID of the registered challenge, of the registered credential. Send it to our authenticator device, look for that private key with that ID, and then again, just do the user interaction, sign the challenge, and send the data back to our server. And then we can compare the signed challenge and use the public key we've stored to make sure that we've authenticated correctly. So let's look at some code. The first time, again, we're going to create credentials, and basically the Web Authentication API has two methods. The first one to create credentials, it's navigator.credentials.create. Pretty straightforward. It accepts one object, it's a JavaScript object, which has some public key information. The first thing you want to put in that is a challenge. Again, cryptographically secure, random array buffer with some data. Has to be at least 16 bytes long, I believe. But it has to be a random challenge. Second up, some information about the relaying party. And the relaying party is actually the website that wants to do this authentication request. So the website you want to log in with, my website, the name of the website, my name, the relaying party information. And this key, this credential that you're going to register is going to be tied to this relaying party, so to the URL of this website. So if somebody tries to use a phishing attack and tries to recreate your website, but it has a different URL, this will not work because it's tied to the ID of the relaying party. Next up, some user information, username, real name, and an ID. ID, again, an array buffer, and anything in this array buffer cannot be linked to your actual username or real name. It has to be anonymous. So it can be just some random bytes or whatever, but it has to be anonymous. And then which algorithms you want to use, because there's a whole bunch of algorithms you can use for cryptography and stuff like this. So you can you have an array where you can specify a bunch of algorithms. -7 doesn't really sound like an algorithm, but there's this whole list by IANA, which lists a whole bunch of algorithms. And if you look up -7 right here, it's ES256, which might sound more familiar than -7. It's just so you can avoid typos. So you give it a list of algorithms that you support in your backend or that you know how to work with. If it's more than one, you can supply more than one. And then you say how much time the user has to complete the registration progress in milliseconds, so 15 seconds in this case. If you want to exclude a certain credential or credential pair, you can do this if you want to, based on the private key ID, which you might have stored in your database. And lastly, some information about the authenticator that you will allow the user to use. So this little USB drive or the built-in one and stuff like this. Authenticator attachment, which means that if you would only want to allow built-in ones, or you would only want to allow external ones, like the USB ones or the NFC ones, you can allow anything if you want from any platform, but you can be very specific in this. User verification, if you want the authenticator to support user verification, so that the user has to verify himself before it can unlock the device. And requires resident key, we'll see later. And lastly, attestation, if you want the data coming back from your authenticated device to be anonymous or not. Sometimes you want it to be anonymous, sometimes you don't want it to be anonymous. So it's a bunch of different values you can change to set up this method, but it's only one method, navigator.credentials.create. To use a previously registered credential, use navigator.credentials.get, again, an object with a random challenge. And then the allowed credential. So if you save the credential for a user in your backend, you're going to pass this along right here. And then again, you can specify if you want the user to be verified or not. So it's much less than the registration method, but it's kind of similar. I skipped over resident credentials because it deserves its own part in this presentation. And what this is, up until now, we've saved the public information of every credential somewhere in a database in our backend, which is cool. It's all public information, doesn't really matter. But you can also just store your credentials on the Authenticator device if they support it. And this will be called a resident credential. So if you set that one to true, and we go to this little website, which has a debugger. Let's see. Right here, so if you go to webauthn.me/debugger, you basically see the whole method I just talked about, and you can change some of the parameters. For example, you want to require resident keys. So if we try to register a new key with this, it's going to ask me, you want to use your USB one or your built-in one? Can you please unlock it? Touch it again. And we just registered one. Now I forgot to change my name, so it will be registered as test and test user instead of some Bellen. But we'll see in the next step how this will be visible. So now we've registered a new pair of credentials. We saved them on the Authenticator device. If we would now want to authenticate with this, we go to the next step, which is navigator.credentials.get, and we don't pass along any allowed credentials, which means that we say to the browser, is there any stored credential on the Authenticator device that you have access to? If so, please allow the user to use this. So if we do that, maybe give me some more time. I have to touch my key again. This will only work if you have a PIN code or something else on your type. But now it will show me a list of all the user credentials that have been saved on my Authenticator device, including test user, which we just registered in the previous step. So right now, without entering a username or anything, I can just log in with test user. And we get the feedback from this. So the Web Authentication API can ask the browser to check the attached or the available Authenticator devices if there are credentials available, and if so, let the user use them if they want to. So that's pretty powerful. You don't have to save any credentials in your backend anymore. The user doesn't have to enter any details anymore. They can just click on the username they want to use or the user profile they want to use. So that's awesome. If you want to try out this debugger, webauthn.me/debugger. So there's still some issues to be solved because it's a quite new API and new things on the web always have some issues. The first thing is user credential management. We can create credentials on these authenticated devices, but we cannot edit them. We can delete all of them, but we cannot delete a certain credential on them for security reasons. So there needs to be a way that's figured out that we can edit these user credentials in a secure way. And for the moment, nobody knows how to do this yet, or the clever people are working on this. That's also possible. Cross-device credentials. If I create a pair of credentials on my MacBook and I want to log into the same website on my phone, these credentials will not be present on my phone. So a way to figure out cross-device credentials is also something that we need to figure out. You can, of course, register multiple credentials on multiple devices and link them all up to your user account for this specific website, but that's not cross-device, that's just multiple credentials. And if you lose your Authenticator device, or if it gets stolen or broken, you might be locked out of your account. So you always need a backup way of authenticating. If you set up two-factor authentication on any website, you always have a backup as well, being a phone number, an extra email address, being it authentication codes. So maybe for this, the backup could be a password. Who knows? Of course not, because we hate passwords, but that could be another backup. So you always need to have a backup in case you don't have access to this Authenticator device anymore. It's a W3C recommendation, so it's not a draft anymore, it's a finalized spec since December last year. And it works in all major browsers, except Safari and iOS for some reason, I don't know why. But if you use the Brave browser on iOS, you can use it together with a Authenticator device that connects through Lightning. So you can use it on all devices in all major browsers. If you use it on iOS, it looks like this. So where can I already use this? Because it sounds cool, but I want to use this on the web, right? You can use this with all major websites, Google, GitHub. Any of the bigger ones will probably have support for it. Probably as a second factor, not as a first factor, because there's still some things that we need to figure out. But it's already available as a second factor on most of the bigger providers and the bigger websites online. Again, if you want to have some more information about this standard WebAuthn.me, it has a nice tutorial that shows you what's going on. I cannot do it in an iframe, but it shows you the whole process of registering and using your credentials. It has some information, and it has a debugger, which lets you change those parameters in those objects on the fly and see what the difference in output is. WebAuthn.me, the spec is surprisingly readable, so if you like to read spec, this one is okay-ish. I wrote a few blog posts about what all of these parameters do, what resident credentials are, so if you're interested in this, go to our blog. It might teach you one thing or two. And if you want to see the slides again, 1990.samego.tech. The slides online are a bit longer. I just trimmed them down for this presentation, but everything is in there anyway. So go ahead and have a look. I would love to have some feedback. So if you have feedback, good things or bad things, but bad things said in a good way, please let me know. Thank you very much.
Thank you very much for this great talk. We have a couple of minutes, ladies and gentlemen, so if anyone has any questions for Sam. Yeah, sure. Got one here.
Let's hear it.
Hi, so you briefly touched upon two-factor authentication. Like, would it not be more secure if you have the password first and the authenticator later than having the password as a failsafe for the authenticator? Like, would it not be secure to have a password and an authenticator?
So you're asking if it's more secure to have a password and a second factor in Authenticator?
Yeah, like I'm asking to have the authenticator, the whole like point of this talk, and the password.
Yes, two-factor authentication is always more secure than one factor. So if you use a password and a authenticator device, or if you use an authenticator device and a authenticator app on your phone in combination, it's always more secure because you have two factors instead of one. So which combination you prefer, that's up to you, but it's always more secure to have two factors. Does that answer your question? Okay, perfect. Next one, I don't know. Oh.
Hello?
Yeah.
So this mechanism talks about having generated credentials and using a PIN to unlock them, basically, right? So what's your take on having credentials not generated, but being something that you are, like a fingerprint or an iris, as an ID, rather than a password?
But you don't want to share your fingerprint data with any third party ever, because it's kind of sensitive privacy-wise. So for example, if you use Touch ID on my MacBook, it will just store this data on my MacBook and use it to unlock this chip to get access to these credentials. But you don't want to share your data, print data, or your face data because that's kind of sensitive. But that's my personal opinion. If you don't have a problem with that, sure, why not? I don't see why you wouldn't want to do that if you don't have a problem with it privacy-wise.
Okay, one more question over here.
I'd like to follow up on this question. So, do you think it will ever be possible and secure, and if so, in which way, to actually uniquely identify humans, not just users and email addresses, but humans, and in that way ensure that a single human is only a single user on your website?
Maybe. It's a very tough question. Unfortunately, I cannot look into the future, so I'm not sure. I would assume so, but yeah, no idea. Sorry. Okay. Do we have more questions, or are we done?
Okay.
Thank you.
Thank you very much.